All right, for anyone playing at home for Compressed 7-8, you missed a few announcements and stuff, but that's the homework. We are starting on 92. 8-92. What? It's fine. Yeah. It's at the tail end of the Math 7 video if people care, but really it was just me being stern with you guys and telling you to behave how you should. Already know. So you are going to make 3 triangles.
Yay.
These specifics tell you what to do. So let's check your construction skills. And actually, part of my math meeting yesterday, we were making that assessment thing I was talking about, and we put one of these questions on there. 3 different shapes that people were asked to construct.
It was when we got here. Someone 5 years ago.
No one takes responsibility, I guess.
Can I have
We're all just going to leave it where it is.
It's 5 Oh, it's this one. It's like, how is that so easy? Give us the measurement. One side length is 4.5
Jessica, what? These are now just laying on the floor for me to step on?
What? What? I thought they were your glasses. I thought first of all you got your glasses back. She has glasses, yeah. She has them at the beginning of the year.
Guys, I'm like going to be real straight up with you. I'm pretty disappointed right now. This is the advanced class wanting to run through 3 courses in 2 years, and I've given you instructions and you're just sitting there. Like, I'm just going to wait until he does it on the board because it doesn't matter. I don't have to do this on. Come on! Do you want to do this or not? And if not, just switch into the other class because trust me, you're not going to want to do all the work for Math 1 next year. I'm sorry to be real straight up with you, but like, we were sharing stories and different stuff at our math meeting yesterday, and like, we got to get this figured out. I have people in here that aren't even doing their homework. You're in the advanced class. You don't want to do your homework, you're in the wrong class. If you don't want to do the classwork, you're in the wrong class. It's your choice, okay? What class you're in is your choice. I should not have to ask 3 different times for people to do something. You should want to do it to test your skills. If you don't, like, we should seriously have a conversation. It's not a bad thing to drop back into the other class. It's okay. But if you really feel like we're moving too fast, we're doing too much, like, we need to talk about switching courses. If you hate doing work in math class, you're probably in the wrong class. Guys, next year you're going to be taking a high school math class. You need to make this decision for yourself. What's up? It's getting frustrated that I have to ask multiple times for real easy tasks. And class started with people trying to carry on their conversations while we were trying to have class. And the thing is, there's probably a couple kids in Math 7 that could have been in this class. And instead, you're in here. So if you don't feel like this is right for you, that's okay. Like, that's not a bad thing. But if you don't feel like you belong in this class, you don't enjoy working with math, let's get this figured out. Like I said, I want to make your life easier. If this class is making it harder, let's figure that out. If someone is confident with their drawing for A and would like to share it, we're going to do these with the dot camera. George, let me see what you got.
Okay.
Yeah.
Okay. Not done with
4.5, 135. So, question is, does everybody, once this loads, does everybody have the same triangle? And if you don't, just be honest. Like, I'm not saying you should have the same triangle. We're investigating. We're trying to figure out, will we get the same triangle? So here's George's triangle. Wonderful header on his paper. He's got his 4.5 centimeters. And his 135 degree angle he put on this side. Does everyone have a triangle that looks exactly like this?
It looks similar.
Looks similar? It's upside down.
One side is longer.
Is that okay? So everyone put their 135 degree angle on the 4.5?
Yeah, I did.
Like on one of the corners? Like one of the endpoints? Because we didn't have to, did we?
No.
Oh, it depends.
You just have to have that angle and you can do it.
Okay. Keep working on B and C. If you're still going on those. I'm curious. So then B gives us two angles. And C gives us two side lengths. B gives us two angles. C gives us two side lengths. A gave us two pieces, but it was one angle, one side length. So then here's my challenge to you. Can you meet the requirements of A, but make a different triangle? Not just turned, not just flipped, but literally a different triangle. Can you meet the requirements for B and draw a completely different triangle? Like not just turned, but actually different. And can you meet the requirements for C and make a different triangle? While you are still drawing those, because I kind of breezed past this, forgot to make this announcement. We're splitting this lesson into 2 days. So I put all of the problems up there because I have multiple times had people texting me because they did not fill in their plan book correctly, trying to figure out what the actual homework was. And when I split things in half, then for some reason confusion happens of were we supposed to do half of this homework or all of it? When I split it to 2 different days, somehow people get confused. So this homework's going to be 2 days worth of homeworks. But I don't know that I'm going to technically make it tomorrow. I may just push the assignment till Monday because you guys have Phoenix Fair and all kinds of stuff this weekend. But you do not have to complete all of these problems tonight. Okay, hear me when I say that. You do not have to complete all of those problems tonight. Gravity works over here. You're welcome. Did you listen to my instructions? My next set of instructions is go back and figure out if you can draw another one. And you also aren't labeled. You gotta label your angles, you gotta label your lengths. Whatever they tell you. Guys, if you've been instructed to make something a certain size, it needs labeling. So just like George showed on his, he labeled his length of 4.5. He labeled his angle of 135 degrees. You gotta do that. Because they told us make this a specific size. Your challenge right now is figuring out, can you make a different triangle that still meets the criteria? in B, are we able to make multiple triangles? In B.
No, because there's two angles. So you have to have. But the side lengths can be different.
Ooh, Micah, say that again.
The side lengths can be different.
So if I... Where'd it go? Got it. Oh, I'm frozen. That would make sense. If we make a 90-degree angle, a right angle, right?
Is it the right thing?
90-degree angle, and then now to make this 60, my bottom would probably have to be shorter. So if this is 60, let's say this angle, I didn't measure it, but let's say I did. And I made that angle 60. It looks pretty close to 60. It's probably closer to 50 than it is 60. But if I make that 60 and this 90, what if I do this? Is it a different triangle?
Yeah.
Yeah. Different size, right? That's a different triangle. Is it still 90 degree, 60 degree?
Yeah.
Yeah. What if I do this? Yeah, if my line actually lined up, it's the same, like, same angle measures, different triangle. I could get bigger too. So, okay, if we're only given angle measures, we can make multiple triangles is what we're saying. We can shrink it, make it bigger. But what if we're only given side lengths? So I have 4.5 and 7 given to me. Quinn, you got a hypothesis here?
Instead of making it 7 and then 4.5, you could make the long line 7 and then 4.5.
Okay, does this have to be a right triangle? Like what you're making with your arms is a right triangle. Do we know what kind of triangle C is?
It can really be any.
But it can't be a equilateral triangle.
I have. Well, want me to show you what I have?
Sure, yeah, bring it up. Let's check out what Quinn's got. Which where's C?
Let's see. That's my
So here's, now he didn't label it, so Quinn needs to go back and label his sides. But here's Quinn's C. Does yours look exactly like Quinn's C?
No.
No.
Yeah.
Might.
Mine's sideways.
So, thank you, Quinn. Label those side lengths, the ones that you were told had to be. Check this out. If I make, sorry, wrong. Clicked on the wrong equal. If we make, what's the lengths we have to make? 4.5 and 7. So we make this 7. Ow. There we go. And we make this 4.5. It depends on the E tool. This one I can't.
Oh wait, no, zoom in a bit. Zoom in a bit.
I'm just trying to get one. Is that the triangle that you have on your paper? Probably not. Here's why that's probably not the triangle that you have on your paper. And depending on the E tool, I could lock this if it was a different E tool. I can rotate this up and still do 4.5. So I could make a right triangle that meets this criteria. I could also make an obtuse triangle. Right there. Am I still meeting the criteria? Yeah. So wait, 2 angles, we've got multiple triangles. 2 side lengths, we've still got multiple triangles. Man, how much do you think we need to give to only have one triangle possible? So I want you to discuss for a moment with your team, what do you think is the minimum amount of information? Because obviously you could say, just say all three sides and all three angles. Duh. What's the minimum information you would have to tell someone for them to build the exact triangle you want? Talk for a minute about that. Three sidelines? Could you? Well, I mean, test it. What if the sidelines were 2, 3, and 4? Like, because you can do that on your graph paper, right? Or like, actually 3, 4, 5 would be easier. So you do 3 and 4 on the right triangle, the diagonal has to be 5. Alright, that was a little bit over. What do we think? Who wants to share what you guys thought? You don't have a group to discuss with. Did you talk with anybody?
I talked with myself.
Okay, Quinn, what did you and yourself decide?
Me, myself, and I decided that you have to have at least 3 requirements for a triangle.
What 3? Or are you saying any 3?
I'm saying any 3.
So if I give you 3 angles?
Then there's only one.
No.
Well,
No, you have to make it.
Because if I go back...
When he kept shrinking that triangle on there, it was the same angles every time.
Ooh. If we go back to here, my angles stayed the same. That is 3 different triangles, all with the same angle. So I like what you said. 3 pieces of information, but 3 angles, we tried that. I don't think 3 angles is enough.
the example that I did had 2 sidelines and 1 angle.
Ah, okay, so let's then your hypothesis is really if you have 2 side lengths and an angle, like that's what you're saying, right? You're almost there. You're like knocking on the door. George?
2 angles and 2 side lengths.
2 angles, 2 side lengths. So George is saying 4 pieces of information. We're shooting for the minimum. So Quinn said 3, George said 4. Jessica? Never mind. Oh. Who else? Other predictions? We're going to come back to this. Well, yes. Because then it makes you want to know. All right, so I'm going to change up how we do this problem. And we may... Hey, Braylon, I shouldn't have to ask you to stop doing that, but you've been doing it for an awful long time. Can you please stop? 7th grade class appropriate behavior, right, guys? In A, so we're on 94. Now, I could have you work in I could have you try to do this on your paper, but instead, I want your group to just think simpler than what we've been thinking. If you look at I, double I, and triple I, which one of those is unique and why? So if you just try to investigate the comparison of those 3 numbers, and yeah, you could think a little deeper and say, we know there are going to be 3 side lengths of a triangle, but if you just try to investigate which set there is weird, take a moment. Now what we're really going to be trying to figure out, I'm going to give you time to talk, what we're really going to try to figure out is, can these triangles be made? Can we actually, if I give you pieces of wood that were 1.5, 5, and 4.5, could you make that into a triangle? If I give you pieces of wood There were 4.55 and 7. Could you make that into a triangle? Same thing with triple I. Can you make it into a triangle? So talk with your team for a couple minutes. Can we make those? Are any of them unique? You're sort of playing like one of these things is not like the other.
One of these things are not like the other.
7th grade class appropriate behavior. You can. We're going to do more with this tomorrow, too. Anyone have a hypothesis here, a conjecture, a idea that we'd like to test? Gabe, I heard some interesting conversation coming from back there. Can you share anything you guys were talking about, or any of you guys, Mallory, Teak, anybody?
Well, we were talking about if you could actually make
Any
any of them.
of them?
Like, or the 3 examples for the...
Okay, so what about it? Like,
I say that you can't make any of them.
any of them? Man, I'm a mean teacher. Put forward a task that can't be done.
And I was thinking that we probably could because like different links could be like slanted and stuff.
Oh, so I like what you said about different lengths. Because did I give you any angles here?
No.
No, I just gave you lengths, right? Jessica?
Well, so like what I kind of think, or like what is like if you have a certain length on the second side, it obviously like it has to like measure up to the like third length. So when I was doing
What do you mean measure up to? I don't.
it had to like it had to be a certain way in order for all of them to connect. So like it.
But what do you mean measure up? You're saying like add up to, like
No,
to equal?
No, like, no, I don't know how to explain it, but I was just thinking like that they all have to be, like all the like lines have to be, sides have to be a certain way in order for the triangle to connect.
So what you're saying is if we have 3 sides, it has to be made in a particular manner, essentially. Like I might not have given you angles, but we might end up with like the same angles as each other because how it fits together. Quinn?
I think it is possible to make all of them.
Why? I mean, defend it.
Because you can, I've noticed something. If you try to make a right angle with any of them, the long side or the slanted side would always be that much longer.
What do you mean that much?
It would be like really, it would be somewhat longer.
So the long side is longer than what?
It's hard to show without bringing it up.
Okay, so give me your eyes for a second. I'm about to show what you're trying to say. Except slightly off because of one of the things you said was slightly off. This is I, right? The first example. I. So I cannot change the length of this because I have it fixed over here. Love the different e-tools in Desmo. So this is a triangle inequality where you type in the lengths or you can slide the lengths. If I bring this point down and I get particular, like Jessica said, I can make a triangle. Yay! Woo! So we can label 1.5, 4.5, and 5. It works. Double I, if I there it is. So my AB, here's my 5, here's my 4.5, and here's my 7. It's not what?
I said it's not always possible.
What do you mean? What would make it not possible?
Like those two B sides, if both of them, if you were to add those two numbers up and they didn't equal the A to the C, they wouldn't be able to reach each other. Like, I don't know how to explain it.
You know, when we were talking about what class you should be in, you should totally be in this class. You should, Micah's on it. He's on the next step that I was debating whether to teach you today or not. So what he's saying is if I look at 5 and 7, what's 5 and 7 add up to?
12.
More than this, right?
Yeah.
What's this and this add up to? More than this, right? What do these add up to? More than that, right? Which I think Jessica was kind of on this idea too, talking about like add up to or add up to. Oh, look at triple I. Smartboard, come on, chill out.
But it's the exact same.
What's wrong here?
When
Peyton.
you add up 4.5 and 1.5, it equals 6, which is less than 7, so that we'll always have a gap and you can never get 7.
Sad day, we can't make a triangle. So, here's the rule. Here's the rule that I need you to get before we leave, because then tomorrow we'll talk about some different rules and probably have some time to work on practice work because we moved kind of quick today. In a triangle. So we can even just say triangle rule.
Triangle.
Now, I'm going to try to make this easy for you. We're going to say the sides here are A, B, and C. So side lengths of like length A, length B, length C. If I add A and B, they must be more than C. If I add B and C, they must be more than A. And if I add A and C, what do you think? It must be more than B. If your triangle does not check all of those boxes, it can't be made. But flip that statement around. If three lengths check all of these boxes, we can make it into a triangle. We got to do it particularly, right? It will come out to be a specific triangle because I gave you 3 boards that like have to be put together in a particular manner, but it can be made. If you're missing any of these, it doesn't work. That is where we're going to stop for today. Have a wonderful day, guys. Not lengths. Those aren't even sides. Those don't even exist. Fall into a black hole. I need real quick Connor, Teak, Braylon, and Simon.
Black holes.
Connor, Teak, Braylon, and Simon, please.